Continuing on, number 7 is Q equals mc delta T. Okay, remember Q is the energy joules, the unit is joules, M is the mass in grams, C is specific heat, grams, JC. Oh no, never mind, I got that backward. Joules, GC, and then temperature, delta T is change in temperature. Okay, change in temperature, which is T final minus T initial. The final temperature minus the initial temperature. So that's the equation. Let us solve this question. Number 7. Find the specific heat of a 6-gram sample. M is 6 grams. Absorbs that 50 joules, so Q is 50. And then heat change from 50 to 30 to 50. So delta T is equal to, the final temperature is 50 minus 30 degrees, which is 20. Okay? So plug it in. Q, 50 equals M. 6 C delta T, which is 20. So if I want C by itself, I would have to divide 20, divide by 6. So the same thing here, 6 and 20. Get that away. So 50 divided by 6 divided by 20. 60 divided by 6 divided by 20. And that'll give me 0.5, that's it. 0.5 joules GC. That's the specific heat of that stuff. Okay? Number 8. What does number 8 say? How much heat must be removed to freeze a tray of ice cube at 0 degrees Celsius and the mass of water is 225 grams? Heat of fusion. So freezing, we're going to use the delta H of fusion there, okay? Which is 334 joules per gram. Alright, so we have freezing. Remember, freezing, there's no temperature change. So the equation for freezing is Q is equal to M times H of fusion. That's it. M times H of fusion. Which is mass is, in this case, the mass is 225 grams times the 334 joules per gram. And that'll give you the heat that needs to be removed. 225 times 334. It's a lot. 75150 joules. About 75 kilojoules, okay, approximately. 75,000 joules. Okay. Number 9. This number 9 here, it's a little strange here. You have an equation. Let me zoom in a little bit here. There you go. This is sort of a stoichiometry problem here. So look at this equation. How much energy occurs when 1 mole of NO2? So we're looking at that. 2 moles will produce that much. Okay. So 1 mole of NO2, we start with that. And we know from the equation 2 moles of NO2 produces negative 114.2 kilojoules. That means it's releasing it. Okay. So then basically take that divided by 2. So it's 57, negative 57.1 kilojoules. Saying if 2 moles produce that much, how much will 1 mole produce? Half of that, right? Makes sense. There you go. Hopefully that makes sense. 10. 2 to back, 2 to back. Okay, now this one, if you remember, it was a summation of the product minus the sum of the reactant of the delta H of reaction of enthalpy. Okay? So get the products, 2H2 and 2H2O2. So oxygen is 0, so that's 0. So the product is 2H2O. H2O is 2 times negative 285.8 minus the reactant, which is 2 times H2O2, which is negative 187.8. Okay? So, do that. 2 times negative 285.8 minus 2 times negative 187.8. And you should have got negative 196 kilojoules for that reaction. some of you, or the way we did it in class, we just got a number here. 2 times that, 285.8 times 2, that's negative 571. Minus, and then this is a 2 times 187.8. Negative 375.6 there. And you get the same thing. Okay? Okay. Number 11. Molarity and dilution here. There should be another equation I forgot to put here. M1V1 equals M2V2. That's a dilution equation. Okay? Calculate the molarity of the resulting solution if enough water is added to 50 milliliter solution to make a solution with this much volume. So you're changing that much to that much. Okay. So notice one is milliliter, one is liters. We got to change this to liters. Well, 0.05 liters, right? Divide by 1,000, you get that. Okay. So M1 is 0.05 liters. V1 is equal to 4.2 molar. I have that backwards. V1, M1, how convenient. There you go. V2 is equal to 2.8 liters. M2 is what we're looking for. Okay? It says what was the resulting solution, the molarity of the resulting solution. Okay. So V1, M1, 0.05 times 4.2 equals 2.8x. Okay? So 0.05 times 4.2 divided by 2.8. And I get x is 0.075 liters. Which, if you want to change back to milliliter, times it by 1,000. 1, 2, 3, so 75 milliliter. Same thing. These two, same thing. Okay. Number 12. How many moles of HCl are present? So with moles, is molarity equals mole over liters. Okay. So number 12, we have 0.7 liters over, and then we have 0.33 mole. And so we're looking for that N up there. Okay. How do you find that? Just cross multiply. Like that, you find the number of moles. So 0.33. 0.231 mole of HCl. It's 12. 13. What's the molarity? You have 125 grams of NaCl, and then you have a 4 liter solution. You have your volume, and you have your mass here, but you need moles. So 125 grams of NaCl, you need to change it to mole of NaCl. Okay? So 58 grams, I'm just going to round to 58 grams of NaCl is 1 mole. Na is 23, Cl is 35. Just for the sake of this problem, divided by 58, 2.16 mole. Alright? So 2.16 mole divided by 4 liters will give me my molarity. Okay? Divided by 4 liters. And you should have got 0.54 molar solution. Okay? Sounds good. 14. 0.33 moles in, so that's the mole. Over liters, I have 450 milliliter. I need to divide by 1,000 to get to liters, so 0.450. So divide by 0.450 moles over liter gives me my molarity. Okay, so divide by that, that's concentration. 0.33 divided by 0.45, 0.73 molar solution. There you go. Number 15, pH, POH. 15, pH is equal to 6. We want to find OH. So to get OH, we need the POH first. Okay. So 14 minus pH will give me POH, which is 8. So OH is 10 raised to the negative 8. And that's a whole number. That's your answer. If it's not a whole number, if it's like 5.4, then you have to go in and punch in your calculator. Okay, 10 raised to the 8. 16. HCl, 0.0001 molar HCl. HCl is a strong acid, so this is your H plus concentration. Okay, and to get pH, it's equal to negative log of 0.0001, and you punch that in, and you'll get 4. Okay, pH is 4 for number 16. Number 17, pH is what we're looking for. OH equals 1 times 10 to the negative 2 molar. So with OH, here it is. OH, you can find POH, which is negative log of that. That equals 2. So the pH is 14 minus 2 will give you the pH. Right, because that's POH. 2 is POH. We don't want POH, we want pH, so 12 is the answer to 17. 18. pH 1.4 is acid. It's less than 7. 19. OH solution is equal to 2.5 times 10 to the negative 4. So if it wants the pH, do the pH by finding the POH first, because it's OH there. So negative log of 2.5 times 10 to the negative 4. Take negative log 2.5 to the negative 4. And you will get 3.60. Okay? So how do I find pH then? 14 minus 3.60. POH. And that'll give you 10.4. That's your pH. And that's number 19. Good luck. Study this. Practice this over and over again. I'll have another sheet ready for you to practice if you want to. Okey dokes. Good luck. Never mind. Goodbye, guys.